Hello. In this video, I want to explain what the purpose of this series of videos is on. It's on generalizing many of the theorems in multivariable calculus under something called the generalized Stokes theorem. And we also discuss integration and differentiation in Rn. So this is a generalization of what you probably have learned in multivariable calculus to the case of n, instead of, say, 3. Instead of three-dimensional things, we're looking at n-dimensional things. And the book that I'll follow is this book by Munkres, Analysis on Manifolds. And this is a book that I pretty much read cover to cover when I was an undergrad, and it's a great book. So in order to understand what I'm saying in these videos, you should get a copy of it. It's quite expensive, but I think it's worth it if you're going to be reading it carefully. And in these videos, I'm just going to give an overview of what's in the book by Munkres, and maybe explain things a little bit differently. But I'm mainly going to just go over the theorems and the basic definitions and some examples to accompany the book. It's not a replacement for the book, so definitely get a copy if you want to follow along. Basically what I do to make these videos is I read the section in the book, and then I think about how I want to present it, and then I present it. And the main kind of goal is the general form of Stokes' theorem, which says that if you have a manifold, an orientable manifold in Rn, and you have a n-1 form, omega, so M is some orientable n manifold with a boundary, and omega is an n-1 form, then the integral of d omega over m is equal to the integral of omega over the boundary. So the boundary of m is this partial m symbol, and the generalized Stokes theorem says that the integral on the left is the integral on the right. Well, of course, to understand what this is even saying, we have to say a lot of things. We have to say, what is a manifold? What is an orientable manifold? What's the boundary of a manifold? And what does the integral over a manifold mean? And then what is a n-1 form? And what's the d omega? What does that even mean? And what does it mean to do the integral of a form? What does any of this mean? So that's basically what we're going to discuss, and we're also going to discuss what this has to do with multivariable calculus. And in multivariable calculus, which I'm assuming you're familiar with, you learn these theorems like Green's theorem and Stokes' theorem and the divergence theorem. And it turns out that these theorems, if you work with it a bit, they can all be expressed as special cases of this general Stokes theorem. And we'll also talk about that. And that's the goal of this class, I don't know, not class, this series of videos, they're not even lectures, they're just a series of videos. And we'll also learn about manifolds. So not just Stokes' theorem, but we're going to learn about what manifolds are in Rn. And these are manifolds in Rn. And we're going to learn about the generalization of derivatives, right? Differentiation of functions in Rn. So we're going to learn a bunch of other things, not just Stokes' theorem, but this is like the highlight of the whole book, is this general Stokes' theorem. And now I should say something about the prerequisites. So what are the things that you would need to know in order to understand what I'm talking about? And they're the prerequisites that are listed in Munkers's book. So you need to know some linear algebra. And this is not just like Gaussian elimination or just computations. It's, understanding what a vector space is. You understand what a basis is, the dimension of a vector space. Some facts about matrix computations, determinants, inverses. This is pretty standard linear algebra, but it should be at the level of knowing about general vector spaces. And some courses in linear algebra don't discuss vector spaces in the first course. So I'm assuming that you were familiar with vector spaces. Mostly we're going to be working with Rn. So really, if you just know about subspaces of Rn, I guess that's okay, but I'll be using the terminology of vector spaces. For the most part, if you're not familiar with vector spaces, then every time I say vector space, just think subspace of Rn, and it should be okay. So that's linear algebra, and then I'm assuming that you're familiar with multivariable calculus. The basic multivariable calculus, the partial derivatives and the double integrals and triple integrals, and you're familiar with parametrizing curves and arc length and things like surface area, integrating a function over a surface, things like the change of variables theorem. These are pretty standard topics in multivariable calculus, and I'm assuming that you're familiar with how it all works, because even though we're going to talk about how it works more generally, this is Rn, and it's going to be hard to understand if you aren't familiar with the basic results in R3. Okay. And then I'm going to assume that you also know some basic real analysis. So I'm going to assume mainly that you know about metric spaces. And you're familiar with open sets and closed sets and compact sets and continuous functions on these sets and basic properties. So this is, you don't need to necessarily know a lot about series, like power series and things like that, but you are expected to know about the Riemann integral, the definition, right, the fundamental theorem of calculus. And so that's quite a list of prerequisites in order to understand these videos. But yes, these are prerequisites. This is a fairly advanced course. The book is mainly written for math majors, I would say. And certainly familiarity with proofs. That you're comfortable with, okay, if you have a theorem and you want to prove it, what do you need to prove? And that kind of thing. So those are the prerequisites. And yeah, and I'll post the videos. I already have posted some. but they're not in order, and that's one of the nice things about making the videos is that I can post them in whatever order I feel like posting them, and I won't go in the standard order. Okay, and again, I recommend that you get a copy of the book to follow along if you're interested in following along, and that you work some of the exercises in the book because they're valuable to do, and that you read along the text together with the videos. You don't just watch the videos, you have something to read, to understand what's going on further, and to have a place where things are written down. And that's all I wanted to say in this video. Thanks.